x plus y equals 12. Now, does that look familiar? Does it look like the quantities added up? Do you know what I'm talking about? It's like,
and it gives you
yeah.
equals
So,
3x.
so here you, okay, and then you have this other one that's like a teeter-totter. Y equals 3 times x. So y was bigger than x, wasn't it? This should look like teeter-totter. So what they did is they did this, if had it been a word problem. So this one's already in the, look at this, plus 0 intercept. Right, the y equals mx plus b. So this one, I call that line 1, it doesn't matter, but here I can subtract x, do you see, from both sides? Do you see that? I'm going to subtract an x. So what will I get? Y equals?
Minus x.
Yeah?
Plus 12.
Yes. Now, what is the slope? Don't tell me x.
-1.
Yes. So you expect to go like that. All right. So, guess what? We're ready to graph practically, right? Because, you know, in this case it wasn't a word problem, but it's the same idea, isn't it? You got two equations. And we put it in a y equals mx plus b. So I'm going to call this line 2, right? So if I make a little, figure out some coordinates, right? When, now this one shouldn't take you long. When x equals 0, what is y? Tick tock, tick tock. Yes, that was the fastest answer yet. Now, that is the y-intercept coordinate, okay? So now if I set the y, I'm going to get the x-intercept. So do you see what happens if I set y equal to 0? I'm going to get what? Minus x. Yes. So I'm going to add x to both sides. Do you see that?
Yeah.
So what will it be?
X equals 12.
Yeah. And the reason it's 12, 12 is because it's the slope of 1. Okay, now this guy is even easier because we already know that when x equals 0, what's y?
0.
Yes. And when y equals 0, so now I have 0 equals 3x. So if I divide both sides by 3, I have 0 equals, right? So that didn't help too much as far as getting another point. But we could pick one. Suppose I put x equals, because we determined the x, guys. So if x equals 1, what is y?
Sorry. 1.
No, if x equals 1, y is not 1.
Yeah, it's 3.
Yes. 3. So that should be sufficient to graph. Now, in this case, if we graph it, this is a capital Y, meaning it has all values of y's, little y's. See, notice I used like a cursive little x here and a capital here because these are for individual points. So if I have 12, so I got 12. So let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, right? And then when that y is here, this is 12. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, something like this. So this one's going to look something like this. And that would be the graph of y2. Do you see? Yes. And this guy, I know when x is 0, it's going through the origin. And is it a positive slope? Line 1, is that a positive slope?
Line 1, yes.
What is the slope?
3.
What is the run?
X.
No, x is never a run. No, x is a variable. The run is 1. Yes, good. And the rise is 3. So we know it's going to go through here, right? For sure. And we picked another point, right? 1. When x equals 1, y was equal to 3, correct? Do you remember this? It's right there. 1, 3. That doesn't look like a 3, but so this is pretty steep because for 1 up and then 3. So that is really the graph of this guy. You see it? So there is an x right underneath this guy, some particular x, I call it critical value, that goes, whatever, goes up from here. And there is a y critical value. We're looking for those as solutions to the problem. Okay? So we want to find that intersection. But that's the only point where we have, y2 is going to be equal to y1. Is only at this point. Right? So let me see, right. Okay. But y1 has a new name. You can call me what? Instead of y1, you can call me right. So what it equals to, I don't know, can't make it harder than that. And what about y2? Right? And since this size has the, the most negative, I'm going to add x. Put the line here. Okay? So that's just going to leave me with 12 equals 4x. Is that true? Is that true? So what do I do now to get x by itself? Yep. So if I divide by 4 and do so on the other side, I see 3 is equal to x. That's the x critical value. It did not, it's probably closer to 3. See, then I got it on 4 kind of. I just eyeballed it, but my graph is not, right? So how do I find the y value once I have the x value? You plug it in either to y1 or y2, because you know what the x is now. Wouldn't it be easier to plug it into this one than that one? Or not really. But x is 3. So if x is 3, what is y? If x is 3, what is y? Huh? 9. Yeah. So this is supposed to be like 9. This is supposed to be 3. You see?
Yeah.
So that should be the answer. Now, if you go back to the way it was in its original form, right? What is x? We said it's 3. And what is y?
9.
And it adds to 12, doesn't it? And the other one we had was y equals 3x. Of course, we know it works. So it doesn't seem too bad, right? This is the mechanics of how you would solve a word problem. I'm taking it one more step because you have to learn how to put the word problem in these two equations. Yeah? What does that look like? Let's see. Okay. Let's go here to Desmos. And we'll just check it real quickly. Do you remember the first one was y equals minus x? Is that right? Plus 12? Or what was it? Minus x plus 12, right? And then we had the second line, and that was going to be y equals 3x. And I can go down like that. Okay, let's take a look at that and drag it down. And let me So graph them, and we hope that our solution is going to be right. Three nine. Okay. Oh, that's easy enough. I just want to get some practice on mechanics. Now, what we were used to doing before I introduced this, I went back to this. Let's see, am I back to here? What we were used to doing, now this was called, what we could have done before I asked you to do the geometric reason, we did something called substitution. And all I had to do is take my yo-yo and stuff my y into my y. Do you remember that? Does anybody remember that? Yeah. That's what we did before we put it into the y equals mx form. We put it in the y equals mx form to help graph it. But you didn't have to. I mean, one way that we were solving it, we were taking our teeter-totter and stuffing it up into the other one. Do you remember? So if I did it like that, I would have, you know, x, right? X. And then I have plus. But y has a new name. What's y? I'm taking this y and stuffing it up my y. But what's the new name for y? Yeah. And now I go back to finish the rest of the equation, which is equals 12. Okay? Is that right? Look how fast this is. This is 4x, right? Divide both 5, we're already done. X equals 3. Takes x equals 3, plug it into any one of these, right? Minus 3 plus 12. A lot faster. Why? Because I didn't ask you to, I mean, if they say substitution, I'm not asking to graph. You understand? So the reason this looks more extensive is because I'm actually having you put in this form so that we can graph. But if it said just substitution and no graphing, which was the fifth problem of the midterm. The fifth problem of the midterm is just, I'm asking just for substitution. I think it's fifth or sixth. The last one, second to last. Yeah. Oh, second to last. So there you have it. Any questions? Is that too easy?
No, kind of how I looked at this when you were first introducing it. I know so much more now.
Yeah. I think they call that learning. So let's try another one. Let's see, just to make sure we got it now. Now that was a pretty straightforward one, so let's do a, how about number 19? That's a homework problem, isn't it? Okay. Does somebody want to give me that? What is it?
2y.
Huh?
2y equals 4x plus 24.
Yeah.
Another one is 2x minus y equals -12.
Okay. So, you know, here's two equations. We're probably most used to seeing y and the x on the same side equals 24. You know, usually that's what you're used to seeing, right? You're saying 2 times whatever y is. In this case, it would be minus 4x would be equal to 24, right? When you set up the word problem, it probably looks like this. You have, you know, some percentage of strength and certain acid plus, let's see, actually this is going to be, excuse me, minus x, right? Yeah, so you can write it as a plus minus x, right? And you could write it as a minus, whatever, it's minus 4x equals 24. Usually you see it, but anyway, they put the x already over here, right? So that was pretty cool. It's cool for us because we want to put it in the y equals mx. Right? How will I get that in the form? What do I have to do to get it into y equal mx plus b? Because we got the x in the right position already. And the number. Divide by 2. I want to get the y by itself. So I'm going to divide this by 2 and this by 2, so I know that y equals, and then I can distribute that 2. So that's 2x plus 12, correct? Yeah. Now, over here, well, I'm going to add 12 to both sides, y. So I'm going to have 2x equals, y minus 12 plus y, right? Because I added y to both sides. Y, yes? So now, that's not quite in the form that I want, so I'm going to add 12 to both sides. So what I have is 2x plus 12 is equal to y, yeah? And since that's equal to that, I can sure write it like this. Correct? Yeah, that's just another rewritten. This, I put the y first, right? So I'm going to call that equation 2, and I'll call that equation 1. Did you understand what I did? I just got the y by itself. First, I got the y over here just to keep it positive. Secondly, add 2x equals minus 12 plus y. Then I had to get the 12 out of there to get the y by itself. Do you see that? So on this side I had 2x plus 12, on the other side I just had a y. And then I just put the y first, because that's y equals mx plus b, where the slope is 2 here. And the slope is, oh, wait a minute, is it the same line? Oh my gosh. Do we have the same line? Booger. Okay. So this looks like the two lines are on top of each other. So where will they intersect? What is the solution? This probably wasn't the best problem, but anyway, it could happen. You have two lines that are, they look different, but when I sorted them out, they're actually the same line. They're not only parallel, they're on top of each other. That's right. For every x, it'll work, right? Because every x will produce the same y as the other line. So you have an infinite solution. Every x will work in both lines, because one on top of the other, they're intersecting everywhere. Okay, so much for that. That wasn't so fun. Okay. So, I guess that didn't work out so good. All right, let's see. Then let's try a word problem like that. Let's try another word problem. Okay. Let's look at number 25 on page 308. Do you see that? This is page 308. Look at page 25. Has everybody found it, or still looking? Everybody find it? Okay, it says you have a 40% die solution to mix with a 70%, right? So we know we have two solutions, correct? So we do have an X and a Y, don't we? And we know that one has to do with the percentage of die strength, and one has to do with just how many liters we have total. So the first question would be is, how many liters do we want total? Or how many total, what is the total amount of liters? Somebody want to read it, or what is it? What's it? 120. So what do we have? Oh, it looks a lot like the problems we've been doing. X plus Y, the number of liters of X plus the number of liters of Y has to equal 120. True? Now, right off the bat, if I subtract an X, what do I have? I have it in the form that I want it for graphing purposes. Is that right? And what's the other one? It's talking about the strength of the die, right? So how much of X? Anyone, we can pick what strength. Just give me a number there. Any one of the two. 40%? So that's 0.4. Plus, and then what's the other weaker one? Or stronger? I don't know. 70%. And we'd like to end up with what strength? A what? We want the total of batch to be what strength? So we have a 40 and a 70, right? What we want is a 50% solution of the total batch. Don't we see it? Or is it only me? You have two strengths, 40 and 70. What do you want to end up with? A 50%. Yes or no? Yeah? Okay. Now, if you notice, 50% of what? 50% of the total batch. That's your second equation. Notice that 50%, check this out, 50% has to lay between what? Between 40 and 70, or it wouldn't make any sense. Now, just look at it and tell me, since I want 50% solution of the total, tell me if you think there's going to be more X or more Y in this batch when we finally figure out what it is.
Is there going to be more Y?
More Y, and how do you figure that?
I guess because there's more in the Y than there would be in the X.
And yeah, but how do you figure that it's going to be more? I mean, what reasoning do you have to think that, why wouldn't X be greater than Y?
Well, my reasoning was 70% is bigger than 40%.
Well, that is true.
That was my thought process.
Just that one's bigger than the other?
Yeah.
No, I think you need to see where the 50% lies.
Oh, okay. So yeah,
So the 50% is laying more towards the X, right?
that makes sense.
So I would think that, the X might have more strength in a sense. Do you understand?
Yeah.
It's pulling. Now, had that been right in the middle, between 40, let's see, so between 40, so say if that had been 45, I would expect that there'd be an equal amount of X and Y. Right? Because it lands right in the middle of the two strengths. You understand what I'm saying? So that's a hint when you look at this kind of problem. So, if I multiply everything by 100, right? I would have 40 x plus 70y equals 50 times 120. Is that right? Okay, so now this side, now I have 50 times 12. Well, 5 times 12 is 60, right? So I think you're going to be at 6,000. Does that look right? No? Well, I know 5 times 12 is 60, right? So 60 has a 0, and then there's 2 more zeros.
Real quick, is that 40x up there part, or is 40?
Yeah, you're right. 40 squeezed in x. Now, do you see that actually I didn't have to multiply by, actually I could have multiplied by 10. So actually I can divide both sides by 10 just to take it down a 0. So what do I have here? 4x plus 7y equals 600. Okay, I just divided both sides by 10 because I see they have an extra 0 on both sides. So I want the y by itself, right? So I'm going to have 7y equals minus 4x plus 600. Do you see that? Now, it's not in the form that I want. I'm going to divide by 7, correct? Somebody say yeah. So if I divide by 7, I'm going to have the y here, and I'm going to have the minus 4 divided by 7x plus the 600 divided by 7. That's kind of weird looking 7, but that's what it is. Let's see, does 7 go into 60? I don't think so. So 7 times 8 is 56. 56 and 4 is 7. It's like 54 or something. Well, anyway, that was this is the problem about mixing chemicals. Okay? So this is strength and this is total. So I'm going to call this Y1 and I'm going to call this Y2. Okay? Any questions about that? Is this written down? Okay. I'm going to clear it up a little bit. Okay, so I have my 2 lines. And of course, I can now decide to do a little chart. I don't know what happened there. Okay. So, if I do a little x and a little y, I can see that when x equals 0, what is y? When x equals 0. 120. Okay, now when y equals 0, do you see what I'm going to do when y equals 0? I'll add an x. So what's x? Yeah. Which makes sense because it's a slope of 1 or negative 1. So let me see what happens when I pick x equals, let's say, 10. When x equals 10, could somebody tell me what y is? Nope. It's a negative x.
Negative, no, it's
110. Okay, now, how about here? Here I have a little x and a little y. So, when x equals 0, what's my y-intercept? Yeah. I always wonder why it takes so long. After a while. Okay, that's 607. And that's like, what is it? 50, 60, 70, 80, 85 or something?
That's 600 divided by 7.
85? Yeah.
85.7.
Okay, so approximately 80, or is it 85.7?
85.7.
Okay, so that's what it is. Anyhow, over here now I'm going to set y equals 0. So now I have 0 equals minus 4x, 4/7 x plus 600 over 7. Seems pretty clear that we can clear out the 7 by multiplying both sides by 7. So I can multiply this by 7, and then this other side has to be distributed by 7. But when the 7's come in, it wipes out. The other 7 divides out, right? So look what I have left. Just a 0 on this side equals minus 4x plus 600, of which I'm going to add 4x to both sides. Do you see that? Now I'm going to divide by 4. Well, I know that x, you can simplify that by 2, right? So that's going to be 300 over 2, right? Which is equal to 150. Are you okay with these steps? Or do you need me to slow down?
No, it's good.
It's okay? All right. So I just solved for x in this chart to help me pick 2 points to graph. Okay, so now we can graph. This is we started from the word problem where x plus y equals 120 liters. And then we had 40% plus 70% to come up with a 50% of the total batch. In other words, the second equation before we manipulated to this position was 0.4 x plus 0.7 y equals a 50% of the whole batch. That was the second line. That was acidic, or the strength of the dye, of the color that you would dye some clothing. Okay, so let's graph. Capital X and capital Y. And the first one, we better go in units of 10, right? Because the first one's 120. So if we go by units of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. This is like 120. And then we have it here, 10, is it 10? Well, I don't know why did I put 10 here? That was crazy. Anyway, that's what it is. I didn't need it. 10, 20, 30, 40, 50, 70, 80, 90, 100, 10, 20. 120. So this is going to look something like that. And that's going to be the graph of y1. Now, for this other guy, we have, when x is 0, y is about 85. 10, 20, 30, 40, 50, 60, 70, 80. About right here. About 85.7. See it? But the other guy, when y is equal to 0, is going to be 150. Yeah, so this is going to be 30, 40, 150. So that's going to look like this. And that's going to be a graph of y equals 2. All right? So our goal is to solve this word problem by looking for this value, what we call our x critical value, that's this C, and whatever y critical value, that should be the solution to how many liters of x and y that add up to 120, such that a 40% strength of x liters and 70% of y liters will give us a strength of 50% of the total batch. Okay. So what do I know about this? What do I know about this point? What about the two lines at this point? They're equal to each other. So that's when one line equals the other line, and only at that point. Yeah, so y1 has a new name. We can call it y1, or we can call it what?
Negative x plus 1.
Yeah, plus 120. And what can we call y2? Y2 is down there.
Negative 4%.
Yeah. Which is still pretty good to go through with 7, right? On both sides. So let me see if I can skip a step without. So I'm going to make this side times 7. So that's going to be minus 7x plus 7 times 100 is 700. And 7 times 20 is 140. Right? So what do we have? 840? And when I come with 7s over here, it ends up just wiping out the denominator. See that? Now, which has the fewest amount of x's? Which side has?
It's the negative 7.
Yes. So I'm going to add 7x to both sides. So all it's going to leave me on this side is 840 equals, how many x do I have here? 3x, right? Plus 600. I think you're going to see, I'm going to clearly subtract 600 from both sides, right? I'm going to subtract 600, do you see? And subtract 600. Well, what's that leave me over here?
So that leaves you with 240.
Yes.
Wait, yes, yeah.
Equals
240 equals 3x. Divide that by 3, and that becomes
the 80x.
80.
So that's what we're this point is here. You can see 10, 20, 30, 40, 50, 60, not too good. But now that I got the x critical value, I'd like to find the y critical value. The y critical value, we can plug either into y1 or y2, we plug in the x. Well, we're saying x is 80. So what do we have? Minus 80 plus 20, right?
Which makes it 40.
Yeah.
So y equals 40.
So y equals 40.
So if you have the original equation, x plus y equals 20. You have 80.
So we suspect this is y1 and there's y2, that the answer's right here. So we can check now right here. So we had y equals minus x plus, was it 120? That's convenient. right? But this guy, he was equal to, what is it, 4, 7, what is it? The second equation. Negative. That negative didn't come out. Negative 4 divided by 7. Right? And then we had what? Plus 600 divided by 7? Plus 600 divided by 7. Okay. All right. Let's take a look. Well, we know that the y-intercepts are around, 120, 85, and our scale is not high enough. I can drag it down. And let's zoom out. Oh, there. That's looking better. So now what we want to know is what's going on right here. That's what we had, right? Yeah. Wow, it's fascinating. Okay, good. So, now, that represents another word problem. So, let's go here. Okay. And, so that was a word problem that worked out okay. Now, let's do 27. Somebody read 27 for me.
Steve, Watnick wishes to mix coffee worth £6, worth $6 per pound, with coffee worth $3 per pound to get 90 pounds of a mixture worth £4 per pound, $4 per pound. So sorry. How many pounds of the $6 and the $3 coffee worth do you need?
Okay, what's the total mixture? How many pounds?
90 pounds.
That's right. That's what you have to be able to look and fish out. So now we're going to have, right off the bat, x plus y again. This is the poundage of what kind of we have? Peanuts and what? What are the two staples?
$6 per pound.
No, yeah, but of what? What's the material? Copy. Hey, you can paste. How do you do that? And I know that the poundage of coffee and whatever it is what, 120? Or 100, what is it? 90. Look how easy that one was. Notice that I'm not talking money here at all. Money is not the issue here. Here is the total batch. That, I think, is probably the hardest thing. I don't know. Or maybe the next line is hardest. But I'm not even going to mess with it because I know that I'm going to subtract x. Look at that. It's already in my y-intercept mode. I mean, slope-intercept. I'll call it equation 1. Okay? Now let's talk money. How much does x cost?
X, do you want to do X in the first one? $6
Okay, let's call it $6 of x
and $3 of Y.
and $3 times the number of pounds of y. Now we want to end up with $4, right? Of the whole batch, right?
$4 per pound.
Of the whole batch. Be careful. That's the whole batch is 90. Just like before, do you remember the amount of liters was x plus y equals 120? It still comes into play here, right? So, well, I'm going to get the y by itself, right? So I'm going to subtract 6x. So now I have 3y equals minus 6x, right? Plus, let's see, 4 times 9. 360. Does that look right?
Yeah.
So obviously I'm going to divide by 3, correct? And you can distribute that under here because it's a common denominator, see? So guess what? I have my second equation. It's equal to minus 2x plus, what, 120?
That's why it's here.
Yeah. So that's y2. So there it is. Here it is. That's how easy they become after a while if you can look at the word problem and say, hey. So, substitution anyway. So, guess what? We can do a little chart now. Right? For line 1, x and y. Okay, this should be getting routine now. When x is equal to 0, what is y? Yes. Y, the delay. Now, when y equals 0, right, I have 0 equals minus x plus 90. Do you see what I'm going to do? I'm going to add x to both sides. So, guess what the answer is? And it should, because it's a not one slope of -1, which means they're always 1-to-1 correspondence, because you're going down a 45-degree angle. Whereas over here, it's even easier, really.
If x is 0,
Yeah.
120.
What's y?
120.
Yes. Hallelujah. Now, what happens if y equals 0? So now I have 0 equals minus 2x plus 120. What would you do?
Divide the 2.
Not really. Well, you could, but you want to get x by itself.
That's you divide 2. So you get -2.
Nope, I add 2x.
Oh, sorry. So it becomes 2.
Yeah, remember, this is always freaking you out. 2x equals 120. I just did it because I have a negative x, but I need the x by itself eventually.
So then x is 60.
Yeah. So, this is how easy this is for figuring how much of each product we should have. It's kind of crooked, but let's say we have, right, so capital Y, capital X, and we're going up units of 10, right, probably, because we're 90. So we go 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we have 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we have, okay, but actually we have 90. So right here is 90, and right here is 90, right? So this is going to look something like that. But we have to go up to 120 here, 90, 100, 110, 120. That's the 120. So that would be for line 2, right? But the other one, when y is equal to 0, x is 60. 10, 20, 30, 40, 50, 60. So that line is going to look something like, this is 60. So that line is going to look like something like this. And that is going to be this. Y2 is a graph representing that. And this one, Y1, right, is going to represent that. Now, we've done pretty good so far, but we'd like to find where they intersect. And where they intersect is only when the two lines are equal, and that's only at this point.
Y1, Y2.
Yes. So, now, we want to solve for y1 equals y2, but y2 has a new name. y2 is equal to minus 2x. Do you see that?
Plus 12,
Plus 120. Yeah.
and y1 is
Yes.
down.
So which side has the fewest amount of x's?
Negative 2x.
Yes.
You add 2x to each side.
So you see I'm going to subtract a 90? So what's that leave me?
30.
Okay, so we're saying this, look at that. That's pretty good. And now, once I have an x, I can plug it into either y1 or y2. This thing that I'm doing is the same process over and over and over and over and over. But now I take 30, right? And what is y? No, positive 60. X is 30. Is not x 30?
Oh, yeah, sorry.
So it's minus 30 plus 90.
And
Okay, so what are we saying this is? Well, we're saying that's what? 60?
60.
10, 20, 30, 40, 50, not too bad. So, given that's rough hand. So now, let's take a look at here. So what do I have? I have minus 2x 120, and I have minus x 90. Okay, so this one's easy enough because that one's just, is it 90? Okay. And then this one's going to be, what was that one? Negative 2x. And then this one? It's 120. Okay. Okay. So that looks pretty good, actually, where we have it crossing. And we want to know what that point is right here. So 30, 60. This is the whole idea I'm trying to get across to you. Not only be able to solve word problems, but to be able to graph. That's a big chunk of the whole course. You're learning how to do word problems and you're graphing. Well, it's good to be happy. Okay. What was that noise? Okay, now, the other problem was, let's see. I guess I can go back to here. Okay, so let's get rid of that. So the other one, I wanted to talk about the Newton's second law of physics. Now, when Newton came up with his laws, there were people actually in physics that thought that the field of physics was over, that there was no more to discover. Because if you know everything going in, and it has a black box process, and then you know what's going out, if you really understand what's going on, you can predict precisely. So people had a cue ball, they hit with a cue stick, and it would go, and it would strike a solid ball, right? If they know the velocity of this thing and the angle of it, the collision should be pretty well predicted in the direction it will go. And so one of the main fields that he found is that the force that you feel against, let's say, a wind blowing against you, is whatever it means, the mass, the weight of the air, times the rate at which it's accelerating. Now, if you're going 10 miles an hour, right, or if you get in a Tesla car, apparently it speeds up really fast. It's an electric motor, and so I don't know, for one reason or another, it's faster than combustion engine, and it takes off. My point is, when you take off, if you've ever been in a really fast car or take off all of a sudden, you will press back into your seat. That is like forming its own gravitational pull. That is acceleration. When you're on Earth, this is called G for gravity. I don't know if you know this, but if there's a tunnel under you right now, if there's a pit, a mine shaft under you, straight now, right now, and I press a button and the floor goes like this, you will accelerate. You will not just fall at a constant, you will not fall at a constant velocity. Every second, you'll be going faster and faster and faster, and the only thing that's limiting your fall is really going to be any kind of friction in the air or whatever. You understand? So, in physics, you'll have a box or a cube that has a certain amount of mass. Let's say 20 grams. Now, we want to know what happens when you have a force that's going against it this way at 30 newtons. That's the measure. And let's say you have another one acting on 20 newtons. And this is on the floor. And for, if there's any friction, we would have to add that like a force going in whatever opposite direction. Okay, so my question is to find the acceleration. That's the question on the midterm. Oh, you got on already?
I have some stuff.
What, the skunk? Skunk come up? All right.
Okay.
Okay. All right. So, how do I come up with acceleration? Well, obviously, the net result is going to be in this direction, isn't it? Because you have more this way. So the net result is this way. Do you see? With a force behind it of 10 newtons. Right? Because 30 swamps out 20. Right? Somebody say right. If I got 20 pushing this way and got 30 in this one, guess what? The 30 wins by 10. Yes or no? So, what's the resultant force? It's right there. 10. So guess what? Now we can put in the 10. Now what's the mass? I have it written right there. 20 grams. And I want you to solve for A. Well, that shouldn't be hard. How do we get the A by itself? Subtract? No. No. That's deadly. Yes, this is multiply. Okay, so that's 1, right? Oh, sorry, 20. So what do I have? We have the acceleration is 1/2 equals A. And that's going to be in, that'll be in, well, this guy, N was in newtons, right? And acceleration is in second per second squared. So that's the answer. So anyway, that was another problem in the,
Because I think I understand these for like visualizing the note, and so that's a bit easier.
See, in physics, every force has an equal and opposite force when you push up against something. For example, the force right now is whatever your mass is times gravity. Gravity on Earth is 9.8 meters per second. Negative because it's pulling down, right? So, if I can figure out the mass now, so what I'm saying is that where you're sitting right now, you have a force of whatever your mass is times the gravity, right? That's the force that's going down, that you're exerting on the Earth, right? The reason that you are not accelerating, the reason that gravity is not, is because where you're sitting, the ground is pushing up at mg. but not minus. Positive. With a net result of 0. If this suddenly stops pushing, you fall. And ever faster, because this is not, velocity means speed. This is the change in velocity, that you're either getting faster and faster or you're slowing down, decelerating. That change in velocity I'm using as the word speed. So if you change from 20 to 40, instantly or really fast, you'll feel it. You'll pull G's when a jet turns, right? It's turning and its velocity is changing. It's creating a gravitational pull, an acceleration. Just by accelerating, and then you turn, and you feel like, what's happening there? You're actually kind of decelerating as you're hitting the bend. Really hard, and then back out again. So this is the first law, or equal and opposite, of forces. Everything you hit or punch, it's punching back. So you punch somebody, it's going to hurt, because their face is going to punch back on your fist. It's not like it's just go, oh yeah, I'm going to go punch you, and it's like idiots when they lose their temper, they hit the wall. I see that all the time. They punch walls and doors. I was in real estate. I go in their house and go, what happened here? Somebody lost their temper. They start kicking and punching the walls, like in the door, and then they say, oh, my hand hurts. And I said, yeah, you idiot. Okay. So that was fun. And then finally, so let's see. So we had the first problem was fractions. Are we all okay with fractions? Are we fractional experts? Good. And then the second problem was, proportion. Do you remember proportions? There was a proportion about a mole. And we were talking about chromium, but I can take any chemical, but let's say it's telling you 1 mole, this is a unit of measurement in chemistry. It's because they say a mole is worth, like 300 billion atoms, because there's so many atoms in just a rain and just a teardrop. There's so many atoms in just a teardrop that they have this units of mole. So, and they said that was equal to something like, what was it? 258, what was it, 258 grams? Huh? 1 mole?
Oh, no. The mass was 51.99.
Okay. So this 1 mole has a mass, which is kind of like weight. Why isn't it weight? I'll tell you why. Let's see. So 1 mole is to 51 grams? Is that correct? Is that right? So, guess what? They'd already told us this basic setup. And because we're measuring another chromium, it's going to have the same ratio. And they want to know how many moles, or this is X, right? How many moles are in 250 grams? What is it? In 250 grams. Well, it's just a matter of solving the algebra. Right? I just want to get the question mark by itself. So I'm going to take 250 grams and I'm going to multiply that on both sides. 250 grams. Notice that the actual grams itself divides out. And so does the number to 1. And notice here that the gram units actually, yeah, because I want my answer in moles. Yeah, there's M. I just want in moles. But how many moles is there? Well, I know really 250, the grams divided out, right? So what I have is 250 times 1 mole over 51. And that equals the question mark. Which is whatever it is. Well, it's almost 50, right? So it's going to, like 5 times, right?
Yeah.
That's good enough. Okay, so that was proportion. And then we had the physics, which was the newtons. And then we had investment. And we had biology. Remember, biology was when we were dumping toxins. Or no, oils fell into there, correct? You remember we had an oil spill? Do you remember how many oil spills? Oh, that's interesting. We have 2. So we have 1 plus another dumped how many millions of gallons? 300 million? So I'm going to leave it like that. She has it right there. Now, I hope you see that's the total batch, right? But now we're talking about teeter-totter. How did I ask you to solve this problem? What's it say there? Solve how?
It just says how much gallons.
What's the first sentence say?
Two largest oil spills together release 322 gallons.
What's it say before that? I had to write something where I said biology.
Solving what problems using substitution.
Substitution. I'm just asking for substitution. I'm not asking you to grab this one. This one has a teeter-totter. I think I was calling X the bigger dump than Y. By what do I have to do to Y to level it out? How many times? What's it say? How many? 2 times? Is it 2 more or 2 times?
It says the smallest released 54 million gallons
Less.
less than the larger.
Oh, so I have to add, don't I? When less means, in order to make this big, I'm going to have to add what? 54? Look, the reason I do the teeter-totter, you have to pick which one you want to be bigger. If X is bigger, then that means this is smaller. You could subtract 54 from here and make it balanced because you're making that lighter. But I'm saying, if you have this teeter-totter and I say X and Y, then there's no way around it but to add to Y to get it to be balanced. No? Yes? Do you see, even though it says it's less, this one, you have to take, to get this one, you'd have to have 54, you have to take away 54 from X. So it doesn't matter which one you pick it, because you can say Y and then X and then what? You've decided to make Y the bigger one, right? Either way, I have a balanced teeter-totter of this, correct? All right, I want to make sure you understand this teeter-totter business, because that is the second equation. And you know what? I'm not even going to bother putting it in Y equals mx plus b. Why? Because the very first part of that problem says solve by substitution. So I'm just going to directly take my x and stuff it up the x. And my x has a new name. What is it? You can call me x or you can call me what? Yes, so I'm going to call this x now, not x, but its other name. Do you see that? And yet, I have to put, plus the y still here equals 300. I just simply replaced the teeter-totter amount of x into there. So, do you agree that I have 2y here? Does anybody agree to that? So if I subtract 54, from both sides, I know that if I take 50, I'm at 250, right? So it should be like 246. Does anybody agree? Equals 2y. Yes or no?
Yes.
So what do I do now?
Dividing something.
Yeah.
Get 123.
Okay, now that I got y, how do I solve for x? Plug it where? Either equation, right? But let's plug it back into teeter-totter, so that we have a circle of life.
So you got x equals 123 plus 54.
Yes.
Pretty easy, it's 77.
Whoops.
177.
Let's see. I say 123. What am I doing? 54. What is it?
177.
177. And that's equal to x, and y is equal to 123. And guess what those two add up to? The total leakage? 300. Okay, so that is substitution. Now, I could put this y equals minus x plus 300, couldn't I? And I could write this as y equals x minus 54. And there are my two equations. And I could go here, but I can actually even graph it without solving on this graph. I think you can just solve it and leave it in what we call the standard form. So I could go here, and then I have, okay, so, let me go. Okay, so I had x, remember the first one, x plus y equals 300. Oh. Whoops. Okay, y equals 300. Yeah. Oh. Okay. That's just leaving it in the form it was, but the graph can figure it out. And the other one was teeter-totter. Do you remember? We had x equals, do you remember it was y plus, is it 54? Uh-oh. Why does it do that? Y equals plus. Okay. So, if we check this out, and let's zoom out a little. No, I zoomed in. Okay. So there are the two lines of which we hope that this. Did we get that? We did? Yeah. Okay. Now, the last one was the same thing, but investment. It was an investment problem. So, how did the investment problem read? We have two investments, I bet. And the two investments added up to how much did the person have to spend on two investments?
600.
That's right. So guess what? Right off the bat, there are two investments of which she had $600 to invest in. Now we're talking interest, so we have to talk about how much interest in one?
5%.
So we could say 5%, that's 0.05, of x plus 3% in y. And that earned a total interest over the whole year of how much? $25. That doesn't seem like a lot, but it's $25 returned on a $600 investment over two different investments. Yeah, it's not too bad. How do I know what rate of return it is? What's 25 divided by 600? Anybody want to know? 25 divided by 600? What interest rate did you get total? Well, how much? Okay, so it should be between,
Goes into 100 4 times, and there's 4, 6 times 4 is 20.
it's 25 divided by 600.
0.
So it won't go in there, right? But it would go in that.
There you go.
How many times? So there's a decimal here, right, at 250. So that would go in what, 4? 2400? That would leave 100. And that would go
It's like 0.04.
0.04? Is that what you said?
If it's 600
Yeah,
25,
yeah.
yeah, it's,
Oh, okay, yeah, because this should have been a decimal point here.
yeah, it's 0.041.
Zero, oh no, forget the zero, because that
So just
point,
0.04.
okay, so that's 4%. So that's better than you get in the bank if you just leave it in your savings account. Anyway, let's see. So, because I'm going to graph it, I'm going to put these in slope-intercept form. So, I'm going to put this as y equals minus x plus 600, and I'll call that line 1. And I'm going to multiply this by 100. Do you see? So that's going to move the decimal place over 2 places, and that's going to make this 2 more zeros. But I want my x over here to start putting it into the y equals mx form. So then I'm going to have 3y equals minus 5x plus 2,500. Do you see that? So obviously I have to divide by 3, correct? So the second line is going to be a slope of minus 5/3 x plus 2,500 over 3. And that's something, what is that, like close to 700 or something? And so I can certainly form a little table here. Somebody tell me fast now, when x is equal to 0, what is y? Ugh, too slow. When x equals 0, that's always the y-intercept, the last number. Okay, when y equals 0, right, what do I have? I have 0 equals minus x. Now, how will I solve that? Yes, I'm going to add x. So I know that x would be, in this case, would be my x-intercept. And that's because it's minus 1 is why the same number. Here, however, here, I'm going to do the same chart. But here, x and y, and x is equal to 0, so what's y?
And your second one, is that the 5x? The 5 over 3x, you're doing that one?
Yeah,
That's just 600 as well, isn't it? Y equals 0 plus
0 plus what?
600.
It's 2,500 over 3, right?
3, yeah.
Is that more like 7?
It's about 800. You can do the exact math.
Okay, roughly. This is for graphing. So now I'm going to set y equal to 0. So if I set y equal to 0, I have 0 equals minus 5/3 x plus 2,500 divided by 3. So you obviously, I'm going to multiply both sides by 3, correct?
Yeah.
And 3 times 0 is 0. That works out really nice. Okay, how am I going to solve that? I'm going to add 5x to both sides. Right? So I'm going to have, in the end over here, I'm going to have 5x. Yes, equals 2,500. So I'm going to divide both sides by 5. Do you see that? Yeah, so now I have my x-intercept. I did that just to figure this other point.
You can plug that into your
No, this is not the solution. This is x and y intercept. Be careful. Yeah, don't want to do that. I'm just doing x every time. X and y intercepts, x and y intercept, x and y intercept. You're not going to get an x that you're interested in until you set y1 equal to y2. Now we can graph it. And like capital X and capital Y. And the first one is 600, right? So I go 10, 20, 30, 40, 50, 60. So when y is 0, x is 600. And when x is 0, y is 600. Right? That's 600. So I can see that that line goes through like that. And that's actually the graph of, see it? Now, the other line is going to be 800. So when x is 0, this is 830, something like this, 600, 700, 800, 900. So something about here would be roughly 830. And now over here we have 500, right? So roughly right here, do you agree? So this one's going to look like something like this. And that's going to be the graph of y2. So we're looking to see how much did this person invest in x and in y. All we know is the total amount and how much interest was paid off of his investment.
Now you do y1.
Exactly, yeah. So now
y1.
I'm going to have to get rid of some stuff here.
y1 is negative 8x plus 600.
Right.
So that negative 5 3x plus 4,500.
Okay, so you're right about that. We're going to set the 2's equal to each other. y1 equals y2, right? y1 has another name. y1 we did as red, right? Yeah. Maybe x plus 600. Yeah. Hallelujah. Minus 5x over 3 plus, right? Yes, by 3. And if we skip steps, we have to distribute, you see? That's going to be minus 3x. Don't let it, plus 1,800. This is a little tricky because you might make a mistake, but here, basically the 3's divide out, right? Okay, which side has the fewest amount of x's? Yeah. Yes. That's right. So- yeah? So actually I'm going to subtract. Yeah. So I'm going to subtract 1,800. Yeah. Yes, now that's your critical value. Now I'm asking you what the y value is. So which is easier, x1 or y1 or y2? Yeah, so if x is 350, that makes it minus 350. So guess what? That means that according to our calculations, she put in that one that she put in $350, and the other one she put in $250. And if you actually take 5% of x, 5% of 250, you know, it's going to be like 5% of 25, right? So 5 of 25, so that's like 5 quarters. So that's like 1250, something like 1250. And now I want 3% of 350. Well, that's 3%. I could just take the 3 and multiply times 300 plus 50. So that's going to be 900. And then that's going to be 3 times 50, 150. So that's going to be equal to something like 1050. So on one they earned 1250, and the other one they earned 1050. I must have done something wrong. So 1050, I'm saying, is what they earned interest. My total interest has to add up to $25, right? So let me see. Let me do that again. I took 5%. Oh, no. I took 5% of the wrong thing. It's 5% of 35. I did it reverse. Let me get rid of this thing. I was just doing a little calculation here to check my answer. Okay. So what I really needed to do was, this is actually 250. Okay. So what I was going to do is here, this means 3%. So I wanted 5% of x. So I want to know what 5% of 300, right? What you can do is remember where your decimal place and just take the first number, 5, and multiply it times 300 plus 50. Okay? So that's going to be 5 times 3 is 15, right? And 2 zeros. And that's going to be plus 250. Do you see that? So that's going to be 1,750. But remember, I had 2 decimal points, right? So that's going to end up telling me that the total amount I invested, 350, at 5%, should give me an interest of $17.50. Now, just take the 3 and multiply it times the 250. Well, that's 3 quarters, right? That would be equal to 750, right? But we have 2 decimal points because it's 0.03. So that means that that's going to add up to $7.50. And that does, in fact, yeah. Now, can you do that on a midterm?
Oh, yeah.
Are you sure? You almost tried to stick the other y in there.
Yeah, I just got too excited.
You got too excited, eh?
I'm gonna take my time.
Okay. All right. Any questions? You're all experts now?
Definitely a lot better than when I started.
Well, I hope so. That's the meaning of getting educated.
Good. This is honestly the farthest I've ever gotten.
Oh, yeah?
Yeah, I've never passed out the.
So you feel better about it now. Let's see. I don't want that. Oh, I want this.